So let's take a look now at example number 1 and see how we can use these limit laws. So the first one, I have a limit here of this quadratic function as x approaches 5. And again, my goal here is to try to figure out how to do these limits algebraically, that is, without looking at a picture. Because if I'm able to do this without looking at a picture, it's going to be much easier to do when I come across functions that I don't know the picture of. So let's see how we can use the limit laws here. I think one of the first limit laws that we could use would probably be something kind of like a combination of numbers 3 and 4. In that, I have a lot of things that are added or subtracted together, and I could separate those out into separate limits. So let's go ahead and write this. I'll start by saying that we calculate that the limit as x approaches 5 of x squared minus 4x plus 3 is going to be equal to, and I'm going to use my limit law, which states that I can kind of take the limit of each term inside of my original expression. So you can see here I'm applying this limit with x approaching 5 to each of these. Okay, so this is really nice. Over on the side, I'm just going to keep a note of what rules I'm using. So I'll say that this was done by laws 3 and 4. Okay. Now, it's really important to note right off the bat that I'm very carefully trying to explain what I'm doing, and I'm going to require, for the most part, that you're able to do the same sort of thing when you provide solutions to me. So notice that means I may have to write out what I'm actually attempting to do. I'm going to calculate something, and then I'm showing all of my work. Notice here that notation is very important. I can't just write limit and then not include x going towards 5. I have to have that on there. Well, now let's take a look at some of these other laws that we could use to help try to calculate this first part. I need to do x squared. Is there anything I could do to tackle x squared? Oh, well, what about like property number 8? This says if I ever have a function like x being raised to a power like 2, I could instead do this as a limit of just the x and then apply the square to the result. Okay, notice over here I have a constant in front of a function of just x. That's kind of like rule number 5. So I could go ahead and pull the 4 out and just leave the x here. And ooh, this last one is actually super easy because I can just use property number 1. The limit of any number, c, is always just the same number, c. So I can have that like this. So notice here, I've used laws numbers 1, 5, and 8. Okay, now I can go ahead and think about, oh wait, now I just have some limits as x approaches 5. And that's just like what I have up here in rule number 2. So this says, just like we saw in this picture, if I'm approaching some value on the function y equals x, then I always just get that exact same y coordinate back. So that means here, I'm just going to end up with the value 5. Then I have to square the result. This limit is going to get replaced with the value 5. And then I have 3. And now that I'm down to all just numbers, I can figure out exactly what this is. 25 minus 20 plus 3, that comes out as a final value of 8. So I'll add one tiny thing here. This is by law number 2. Okay, so this is actually great. We were able to calculate a limit using only the limit laws. So as long as the above limit laws are true, which again we'll show in section 2.5, then this is completely consistent with those laws, and we have ourselves a good answer. The y value that we approach on this graph is 8. All right, well, let's try this again. In fact, I'm going to ask you to see if you can try to do this again here on part B. I'm going to ask you to pause the video right now so you can try to work through this and try to be careful and notate everything very, very carefully, just like we did up here in part A. And when you unpause the video, you'll see me work through the solution. Okay, well, hopefully you went ahead and you got some answer for this already. but I'm going to go ahead and write out what I got. So I would say that I'm going to calculate this limit, and one of the first things I'm going to notice here about this limit is that I have the limit of a fraction. And so I'm going to start by trying to just take the limit of the top and the bottom separately, because that's going to correspond to limit law number 7 right there. Okay, so let's see. So this is going to turn into a limit, x approaches -2, of my x to the third plus my 2x squared minus my 1. And then on the bottom, I'm going to have limit as x approaches -2 of 5 minus 3x. Now I'm going to start to try to combine a whole bunch of my rules at once, and you're more than welcome to do so as well. So notice here, I could go ahead and now say that my numerator is going to turn into, actually, I could separate this out and apply a bunch of rules. I could do the limit as x approaches -2 of x, and then cube the result. That's a combination of using 2 rules from the box up above. I could then pull out a constant and do the limit of x as x approaches -2 and square the result. A combination of the same rules plus 1 more where I pull out the constant. And then of course I have the limit here of -1. Okay, in the denominator I can do the same sort of manipulations. I'm going to have the limit as x approaches -2 of the value 5. And I'm going to subtract from that. I'll pull the constant out and just leave the x right there. So now I can try to evaluate each of these limits, and they're pretty much all very, very, very simple. The first limit here is going to be -2 to the third power. This limit's going to be -2 squared times the 2 in the front, and the limit of -1 is just going to be, oops, sorry, I've had a typo here. I already accounted for the minus here. This should be a +1. So here I should just end up with limit 1. In the denominator, I end up with just 5, and then -3, and that limit's -2. Notice if I go through and I evaluate all of this out, I'm going to get -8, then I'm going to get +8, and then I'm going to end up with -1. In the denominator, I'm going to get 5 and +6. And so I think in total here I end up with -1 over 11. And I have an answer. Now notice I didn't specify here exactly what limit laws I was actually using. And that's totally fine. On exams and on homeworks, you will not be required to tell me exactly which limit law you were using. So you don't have to memorize them by number. But you should be aware of when you're using a limit law and when you're just kind of making up something. We want to make sure that we're only making manipulations that are valid by the limit law. Now what's kind of interesting in both of these questions, and some of you may have noticed this already, is that in the examples above, we see that the final limits could have actually been obtained by just taking the number that x was approaching and plugging it in. Right? I mean, like, take a look at this. This is x to the third plus 2x squared minus 1, 5 minus 3x. Isn't that exactly what I have here? Just all my x's were replaced with -2's? Now, if I take a look up here, the same sort of thing happened. I had x squared minus 4x plus 3, and x was moving towards 5. And right here, don't I have the exact same thing except x has been replaced with a 5? This is really weird. But the following theorem shows us why this is happening. This will not happen all the time. This is what we call the direct substitution property, and it's important again to read all the words. If f of x is a polynomial or a rational function, that is the division of two polynomials, and if a, the thing I'm approaching, is in the domain of f, that is I can plug it in, I can get a result back, then instead of using all the limit laws, I can actually just imagine plugging the a in for my value of x, like we saw up above. So this is a really, really powerful idea. And again, this is something that we can see. We see this in examples 1a and b. Okay? We could actually go back and see how this actually worked there. So the important thing to recognize here is that this property doesn't work all the time. It only works if I have a polynomial, which is something kind of like this, where I have x's to whole number powers, maybe added or subtracted together with other terms. Or if I have a rational function, which is like what we had here in part B, where I have a polynomial up top and a polynomial on bottom. If I don't have one of those things, I do not know yet if I'm able to just plug stuff in. I have to use limit laws and be careful. The other thing that's important here is that I have to make sure that a is in the domain of the function. And we'll see where this becomes important in the next example.